Okay, we have a situation here where we're going to construct this enclosure. It has two sides, each of length L, that's made out of brick, and three sides, each of length W, that's made out of wood. The brick sides cost $40 per foot, the wood sides cost $28 per foot. What is the maximum area you can enclose for $5,000 now, to the nearest square foot? So here's an equation expressing the total cost. We have $5,000 to use. That we have to pay for the bricks plus the wood. There's $40 per foot, and 2L is how many feet of bricks we need. So dollars per foot times the number of feet, that's how much the bricks will cost. This is the dollars per foot, and the number of feet we need for the wood is 3 times W. W is the width. So that's the total cost of all the wood. So this is the cost equation here. And we can simplify it by dividing both sides by 4. Okay, so we end up getting 1,250 is equal, 4 goes into the 40 10 times, so it's 10 times 2L, plus 4 goes into 28, 7 times. So dividing the 4 into each term in the numerator, we get this, or 20L plus 21W. Anyway, now what we need to do is to solve for one variable. We're trying to maximize the area. The area is simply equal to length times the width. So we need to use this equation to substitute one of these variables. And I think I'll substitute, let's solve for L in terms of W. So to solve for L in terms of W, we'll subtract 21W from both sides. And we end up with 1250 minus 21W is equal to 20L. And if I now divide both sides by 20, we have then found that L is equal to 1250 minus 21W all divided by 20. Indeed, we could write this as L equals 1250 divided by 20, which is 125 divided by 2 minus 21 divided by 20, W. So, what we're going to do now is substitute this value for L into the equation for the area. And what we then have is that the area is equal to 125 divided by 2 minus 21/20ths W times W. Or the area is equal to 125 divided by 2 times W minus 21/20ths W squared. And so it's a parabola. We're trying to find the maximum area. That'll be the highest point on the parabola. So this parabola is a function of W. The area as a function of the width W. The maximum area is attained at the vertex. So we need to find the vertex of this parabola, and then we'll know the maximum area. So let's work on that. Let me rewrite my area equation. The area is equal to negative 21/20ths W squared plus 125 divided by 2W. So we need to find the vertex of this, and the x-coordinate of the vertex is, in this case, is the W coordinate of the vertex is negative b over 2a. In this case, that's negative 125 divided by 2 divided by 2 times a. A in this case is negative 21 divided by 20. The 2 down here cancels with the 20, so this is, and the negatives cancel. This is 125 divided by 2 over 21 divided by 10. If you invert and multiply, you get 125 divided by 2 times 10 divided by 21. And the 2 goes into the 10 5 times. So we end up having 125 times 5. Divided by 21. So this is 625 divided by 21. That's the width that will yield the maximum area. Okay, now to find that maximum area, we have to substitute this value of W into the equation for the area. So here we go. And this is a numerical calculation, so we can start using our calculator, but it'll make it easier if I factor as much as I can first. So I can factor out W divided by 2 from this. So we end up with negative 21 over 10 times W plus 125. So plugging in now, the W that we have, 625 divided by 21. Let's do that numerically. Numerically, this is approximately equal to 29.761 approximately. I'll go 0.476. And that's in feet. That's the W that will yield the maximum possible area here. So we're plugging this in for W into the equation. And I'm going to store, it helps if you store it in your calculator. Here we go. So the maximum area we get by taking this value of W and multiplying it times 21 and dividing that by 10. The negative of that, that's 62.5 by the way, plus 125. So that's 62.5 in there. So that times W divided by 2 will be our answer. So what I get here is that the maximum possible area is 930.059. Anyway, to round off to the nearest square foot, that would be 930. So the area is approximately equal to 930 square feet. And that is the maximum possible area for this enclosure for $1,000.